Hi, this is Govind Joshi from ETT Celebrate to Support Private Limited. This is our product design. This is our product assembly looks like, which contains complete water filled inside, and this is a car inside which operates inside the fluid medium. I'll show you some of the schematic of this design inside out. Okay, this is a schematic. This container consists complete of fluid or water in this case. This elevator car is made to operate, move up and down without any power with the help of weight. Once it gets loaded, it will comes down, and when it gets unloaded, it will move up without any requiring external power. In half section, we can see the car, the container, the stoppers, everything. These are sidling. These are the sliding support guide bush that supports the car for sliding. This is a waterproofing tech, where when the car and the container door comes in alignment, the stripper pushes against the gasket in order to provide no fluid area at loading and unloading positions. Okay, these are some of the snaps where we can see the open door condition, and this is the loading area. This is a loading area. This is the manufacturing, one manufacturing typical drawing. Uh, okay, we have got this design validated in terms of hydrodynamic or CFD analysis in order to ensure the workability of the product, and the structural analysis in order to ensure the structural integrity of the product during operation. CFD analysis. Our objective is to ensure feasibility of the car motion for permissible speed of the velocity, and ability to control the velocity of the car. And this is the flow path as defined. This is the top view of the product. The shaded area is the flow control area, and we can control the velocity of the car by controlling the flow at these areas. So we have calculated the forces. The car we have designed is of 30 centimeters length and 30 centimeters width, of around 37 centimeters height. The weight of the car is 226 kg, and when we calculate the upward force, it is of 122.56 newtons. So the empty car moves upwards without any velocity, no, without any power, with 122 newtons. So when we calculate the downward force, when the car is loaded with some weight, in this case 20 kg we have added, so that it generates the downward force of 73 Newton without requiring any external power. This is all theoretical. So we thought of developing one small glass testing model. So we have calculated the downward and upward force, and so that we can see the operation. We have got the downward force of 4.905 newtons, and the upward force of 19.62 newtons. So there is very much feasible this design can operate fluently in the fluid medium. So we have got calculated the terminal velocity that comes to 1.2 meters per second, which is exactly within the permissible range. That is, we in our conventional elevators, the velocity of around 1 to 1.5 meter per second. So we can control this velocity using the flaps and all. I'll just show you that one. And while the velocity while going upwards, it is 2.323 meter per second. Uh, these are the flaps which are used to control the velocity of the car. We can set these flaps in any position, open or close. So we can control 40% of the flow area. Uh, And also we have got stoppers and steppers to retard the motion of the car. In conclusion, fluid path is defined, and the working feasibility of the design we have developed is just very fine. Okay, this is a structural analysis of the product. Here the objectives is pretty simple: self weight analysis, stopper analysis, where you should hold the pressure and vibrations of the car, and the slider analysis, the pressure due to the fluid. This is a material we considered SS316, that is a high grade stainless steel, corrosion resistant one. The total mass of the assembly we are planning to manufacture is of 316 kg. These are the FE modeling details, number of elements, number of nodes which are very much under controlled criteria. These are stress plots of the bottom stoppers, and the self weight analysis of the container, and this is of car, and this is of stoppers. So all in all, with the factor of safety more than 1.5, the car is very structurally in integrated, where we can operate sufficiently with the load of from 20 to 50 kgs.